Okay. Hey, this video is meant to be an introduction to the law of Hess, or you can say Hess's law. Um, it's another way to calculate the heat associated with a chemical reaction. So calculating the delta H, standard, the change in enthalpy. You'll notice what we're trying to do here is calculate the delta H for this reaction. So you notice methane. You notice the reactant's oxygen, but you notice the products are carbon monoxide and water. So what do we call this? What kind of combustion is this? This is incomplete. Yeah, incomplete combustion. So what we have though here is we know the heat associated with these two reactions. And so what we can do is use these two reactions and their change in enthalpies to determine the change in enthalpy, the heat associated with this reaction. All right, so let's get started. These are the two reactions we're going to work with. Now notice that this first equation has something in common with this overall reaction, this reaction. There's a couple things here. It has water. It also has methane. Now it also has oxygen as well, but this one has oxygen too. So what you want to do is start with an equation that has a reactant or product in it that's unique only to that equation. So this is the only one with methane. So let's start with that. But notice there's two of them. So what would we have to do with the, reaction number one? We'd have to double it. Yeah. So let's double it. So I'm going to show the work right here. So it's like 2 times reaction 1. So we'll have 2 methanes plus 4 oxygens yields 2 carbon dioxides plus 4 H2O. Now what do you think would happen to the delta H? Sure, it would get doubled too. So let's just double that. We'll just show it like that, okay? All right, so we have, let me just use a different color here. We have, this is exactly what we want. We want 2 methanes. We have 2 waters. But there's a couple issues here. Here we have 4 oxygens. There's only 3 here. And here we have carbon dioxide. We want carbon monoxide. So how can we use equation 2 to get rid of this carbon dioxide and introduce carbon monoxide? Well, there it is right there. But what do you notice? This carbon monoxide is a reactant. That's a product. So let's flip that equation. So what we typically write is -1 times equation 2. So we're going to make the products products. So we're going to write 2 CO2 yields 2 CO plus O2. Now what do you think we're going to do with that? If this reaction is exothermic in this direction, what do you think it's going to be? Yeah, endothermic. So the way I'll show that is I'll just take negative of the negative 566. Okay? All right. So now what we can do now is add these up, and we'll get 2 methanes plus 4 waters plus 2 carbon dioxides yields 2 carbon dioxides. Oh, interesting. Plus 2 carbon monoxides plus an oxygen plus 4 H2O. And you notice those cancel out. Just think of it as an algebraic equation. And notice here, there's 1 oxygen here and 4 here. So if we subtract 1 oxygen from both sides, that'll cancel out. And this will turn into 3. And if you think about this, it's exactly what we want. There's 2 methanes, 3 oxygens. It yields 2 carbon monoxides and 4 waters. Hey, so what do you think we do with those delta H's? Yeah, we just simply add those up. That's what Hess figured out. That if you can just add equations up to get another equation, then the delta H's of those equations can be added as well. So let's add those up. I did that earlier, and I got negative 1241 kilojoules. Let me just check my calculator here. Make sure I got that. Negative 1214, excuse me. Negative 1214. So there you go. Hess's law. Now, so let's kind of review here. We're going to have an equation we don't know the delta H of. We have other equations whose delta H's we know. And we can do various things to these equations. We can double them, we can triple them, we can take 1/2 of the reaction, take 1/2 of this, we'd have to take 1/2 of that, and we can also reverse the equation, make the products of reactants products. And you want to start with an equation that has something unique in it that corresponds to what's in the overall reaction. So we started with this. Now we could have started with this, but what would we have done? We would have just simply reversed this. We ended up reversing it anyhow, but you could have started with that. But both of these have oxygen, so don't start with one. Don't multiply it by this 3. Don't multiply this by 3 thinking it's going to work out. You have to just trust that the oxygens are going to cancel out. Okay, I'll make one more video looking at a little more complicated Hess's law problem. And then like all things in chemistry, almost all things in chemistry, you really do need to practice this. So you need to push your pencil or pen, PYP it, all right? I'll give you a few to do. And I'll probably provide the answer so then you know you're doing the right thing. But I want you to show your work like this. All right, the law of Hess, or Hess's law. All right, thanks.